If you haven't lived under a rock for the last few years, you will have heard of cryptocurrencies and related technologies like blockchain and smart contracts and NFTs. You probably also have heard that these are investable assets and some people have made a lot of money investing in them. Maybe you've even bought some Bitcoin for yourself. But what are cryptocurrencies really and how do they work? We will answer these questions and more in this video series. Let's get started. Hi, my name is Daniel, a retired meta software engineer, and this is my channel, Gainfully Unemployed, where I talk about topics like investing, personal finance, and financial freedom. If you want to see more videos like this, then subscribe to my channel. So, what is a cryptocurrency? A cryptocurrency is a distributed ledger keeping track of account balances through transactions written to a blockchain, which is validated and secured by a network of validators and miners. With that, thank you for watching and see you again. Okay, I know what you're thinking. That's obviously not helpful. You might be able to win Bitcoin bingo with a sentence like that, but it doesn't really help us understand cryptocurrencies any better, unless we understand what these words actually mean. So let's look at the sentence a little closer. A cryptocurrency is a decentralized ledger keeping track of account balances through transactions written to a blockchain which is validated and secured by a network of validators and miners. In this video, we will take a closer look at the concepts of a ledger, accounts, transactions, and how those are stored using something called a blockchain. A ledger is like a log or a database that is used to store transactions and account balances. By accumulating all transactions within a ledger, you can derive the account balances of the accounts being tracked with that ledger. For example, a single deposit transaction for $100 to account A will result in an account balance of $100 for account A. If another transaction is added that transfers $25 from account A to account B, you now have two accounts with balances. Account A with 75 and account B with 25. If a third transaction is added that withdraws $50 from account A, then both accounts now have a balance of 25. What the ledger stores are the transactions, not the account balances. Summarizing over all the transactions will give you the current state and balances of all the accounts. An account in the cryptocurrency world is identified by a wallet address. A wallet address, on the other hand, is cryptographically tied to a public-private key pair. Typically, the wallet address being derived from the public key, for example, by hashing it. This is important for securing the blockchain and verifying the origin of transactions. But we will talk some more about account verification and general cryptocurrency blockchain security in the next video, as well as about accounts that are not tied to a public-private key pair. For now, know and assume that an account is equivalent to a cryptocurrency wallet address. We talked about transactions a little bit already. The most basic and most common transaction on a cryptocurrency blockchain is the pay to or transfer transaction. Different cryptocurrencies and blockchains call this transaction slightly different things, but basically what it does is transfer a certain amount of the blockchain's native currency from account A to account B. There are other transactions on most cryptocurrency blockchains, like op return on the Bitcoin blockchain or contract creation on the Ethereum blockchain. But those are more advanced transactions and concepts, and for now not really relevant for explaining the basics. Like in a ledger example before, a typical transfer or send-to transaction includes a sender, a receiver, and an amount. For technical and security reasons, even simple transactions like these typically include more information than just these three pieces, but they will always include these three pieces. The sender and receiver will typically be a wallet address in such a transaction, and the amount will be denominated in the blockchain's native currency. That is Bitcoin or BTC for the Bitcoin blockchain, and Ether or ETH on the Ethereum blockchain. New transactions are added to the blockchain not individually, but in blocks of transactions. That's where the block and blockchain comes from. Typically, each block has a size limit, limiting how many transactions can fit into a block. For Bitcoin, that is 1 megabyte worth of transactions, and for Ethereum, it's 30 million gas worth of transactions. We will talk about gas some more when we talk about smart contracts in a later video. For now, know that each transaction in Ethereum requires a certain gas cost, and Ethereum limits the block size by specifying how much gas fits into a block. Miners verify transactions in every new block and try to mine it. They do that by repeatedly trying to solve what is commonly referred to as a cryptographic puzzle. We will get into more detail how this works also in the next video. For now, know that once a miner has found a solution to this puzzle, it will add that solution to the end of the block, including a transaction which rewards the miner a small reward for finding the solution. The miner will then cryptographically link the current block to the previous block and sign everything so it can't be tampered with or altered anymore. The miner has now created the next link in a chain of blocks, the blockchain. The blockchain is called that because that's what it is, a chain of blocks, each cryptographically and uniquely linked to the previous block. This chain of blocks creates a unique and unchanging history of transactions, and when summarized in its entirety, will create the state and balances of all accounts tracked in the blockchain, a ledger. The fact that this history is unchanging is important because it makes the blockchain resistant against tampering. Fundamentally, the mechanism with which the blockchain ensures that this history is unchanging is with a cryptographic hash. A hash is a cryptographic function that, when applied on an arbitrary amount of data, produces a fixed length output. Provided with the same input data, a hash will always produce the same output. And even small variances in the input data will produce significant changes in the output. If you have the hash to some specific data, you can check the integrity of data provided to you claiming to be the specific data by rerunning the hash function on the provided data and checking the output against the hash that is well known to you. If the data was altered or damaged somehow, the generated hash will not match. Hashes are also one-way functions, meaning it is computationally cheap to go from data to hash, but expensive, if not impossible, to go from hash back to data. The unique properties of hashes are used all over cryptography, and cryptocurrencies are no exception. One application of hashes in cryptocurrencies is to ensure the integrity of the blockchain. When a new block is mined and added to the blockchain, this link is created by using the previous block as hash. That makes it impossible to tamper with the history of the blockchain after the fact. If I were to go and change any of the transactions in the previous block, the hash for that block would change because the content of the block changed. This will lead to the hash in the next block no longer referring to the block with the altered transactions. Ultimately, what this results in is an append-only log. Once added to a finalized block and linked to the blockchain, transactions cannot be undone anymore. If you wanted to undo a transaction, you would have to instead do the reverse transaction and add that also to the blockchain. This is an integral part of the blockchain integrity and security model, but like all security models, this can also get in your way. In June of 2016, a hacker was able to exploit a small bug in a smart contract on the Ethereum blockchain and stole millions of dollars worth of Ether. Without the ability to undo the transaction and the hacker not willing to voluntarily return the funds, the Ethereum project had to make a hard choice. Would they honor the integrity of the Ethereum blockchain and let the hacker walk away with millions of dollars that they stole from Ethereum users? Or would they do a small but non-backwards compatible change to the core Ethereum implementation that would specifically undo the transactions that the hacker had made? This would risk a hard fork of the Ethereum blockchain. A hard fork of a blockchain effectively occurs when not all miners and wallets update to a new required software version of the underlying protocol. The miners and wallets that do update will start producing a diverging blockchain from the ones that do not. Suddenly, two versions of the blockchain exist. The hard fork rolled back the largest Ether theft in the history of the Ethereum project. At least it did on the Ethereum blockchain. The nodes on the so-called Ethereum Classic blockchain did not update their protocol and did not adopt the hard fork. Yes, there are now two versions of the Ethereum blockchain. One in which millions of dollars worth of Ether were stolen by a hacker, and one where they simply have not. Thank you so much for watching the first part in my Cryptocurrency 101 series. The next episode will take a closer look at what mechanisms are employed to keep cryptocurrencies and the blockchain safe, without requiring any participant to trust anyone else. I will link that video in the pinned comments below as soon as it becomes available. If it wasn't released yet, or you would simply like to see more of my videos, please subscribe to my channel and hit the little bell icon so you get notified as soon as I release new stuff. If this video was useful to you, please leave a like. And if there's anything I missed or if you have any other questions, please leave them in the comments below. Thanks for watching. See you next time. I'm Daniel. This is my channel, Gainfully Unemployed.